All right, today we're going to tackle a concept that's, and I'm not exaggerating, going to completely change how you write code in C. We're about to move beyond just using the language and start becoming an architect with it.
You know, this quote right here, it just perfectly captures the moment we're at. Think about it. We're moving from being someone who just uses pre-made tools like printf to someone who actually designs and builds their own. This is a big step, so let's get into it. So, we're kicking things off with a huge shift in perspective. Creating your own functions, it's not just another skill to learn. No, this is the exact moment you start thinking like a software architect. You're not just writing lines of code anymore, you're designing reusable components. Let's try an analogy. Imagine you're a carpenter. Now, standard C functions like printf, those are the hammers and saws you buy from the hardware store. They're reliable, they get the job done, but they're limited. But the custom functions you're about to write, something like sum last digits, that's the specialized jig you build yourself for one very specific, very important job. See the difference? You're not just the carpenter anymore, you're the tool inventor.
Okay, so if we're going to build our own tools, we first have to understand how they're put together, right? We need to know their anatomy. So let's put on our architect hats and really dissect the DNA of a C function. Just take a look at this single line of code. This is called a function signature. And believe it or not, it contains pretty much everything we need to know about our new custom tool. We're going to break this down piece by piece over the next few slides.
First up is the return type. That's the int right at the beginning. You can think of this as the output. It's basically a promise you're making to the computer. You're saying, hey, when this tool is all done with its job, it's going to hand you back a whole number. If it said float, well, it would hand back a decimal. Simple as that.
Next, we've got the function name, sum last digits. This is the label. It's like the brand name stamped on the side of your tool. It's totally unique. And when you need to use this specific tool, you call it by this name. That's how you activate its power.
And finally, we have what's inside the parentheses, the parameters, int a and int b. This is the input. It's like the instruction manual for your tool. It tells the rest of your program, look, to make me work, you got to give me 2 raw materials, and both of them have to be whole numbers.
You know, to really tie all this together, just think of your function as a juice blender. It's a perfect analogy. The inputs, your parameters, are the ingredients you drop in, like carrots and oranges. The blender's internal mechanics, all the spinning and chopping, well, that's your function's code, the process. And the output? That's the fresh juice that pours out at the end. That's your return value.
Okay, theory's great, but now it's time to get our hands dirty. We are now going to actually build our sum last digits function, step by step, right from the ground up.
Step 1 is what we call the promise, or more formally, the function prototype. See, C reads your code from top to bottom. So by putting this line before your main function, you're giving the compiler a little heads up. You're saying, hey, just so you know, a tool named sum last digits is coming, it's going to need 2 integers, and it'll give you an integer back. This way, when main tries to use the tool, the compiler doesn't panic. It knows the tool is valid, even though it hasn't seen the detailed instructions yet.
Step 2 is where we actually put our new tool to work, right inside the main function. We just call it by name, give it the inputs it needs, in this case some variables x and y, and we catch the result that gives back. And here's a really key idea. From main's point of view, we don't care how this tool works. We just trust that it does. It's kind of like a little black box.
And here it is, the final step, the recipe. This is the function definition. This is where we lay out the detailed, line-by-line instructions for how our tool actually operates. We take the inputs, a and b. We use that handy modulo operator, the %, to grab just the last digit of each number. Then we add those digits together to get our sum. And then, this is the most crucial part. We use the return keyword to send that final sum right back to wherever the function was called from.
Now, everything we've just done builds up to what might be the single most important concept you'll learn as a new software architect. Seriously, this one idea will fundamentally change how you think about programming.
So here it is, the big secret. A function is a black box. That's it. That's the golden rule. Once you've built your tool and you know it works, you don't ever need to think about its inner workings again.
So, as the architect of the whole program, your main function only needs to care about 2 things: what raw materials go into the box and what finished product comes out. The complicated machinery inside, that's all self-contained. And that is the secret to building huge, complex, manageable software without getting totally lost in the details. All right,
You've learned the theory, you've seen the anatomy, and you've been told the big secret. Now, it's time to test out this new power of yours. I'm going to throw a few questions at you just to see if these concepts have really clicked into place.
First question. Let's look at that function signature again. What does that very first int represent? What's its job? I'll give you a second. It's the promise of what the function will give back. It's the output type.
Okay, now for a critical thinking one. Imagine you're inside your function definition, and you change that line return sum to return 0. What value is your main function actually going to print out? Think about it. It will always print 0. Why? Because that's what the black box is now hardwired to give back, no matter what awesome ingredients you put into it.
And for our final question, could you name this function getPizza instead of some last digits? Would the computer care? Would it stop you? The answer is, technically, no. The computer doesn't care what you call it, as long as you're consistent. But naming it something that clearly describes what it does, now that is what separates a simple coder from a true software architect.
And that brings us right here. You now have the blueprint. You understand all the components, you get the process, and you know the core black box philosophy. So really, the only question left is, are you ready to stop just using tools and finally start building your own?